Okay, so today we're going to talk about the alternating series. So because English is not my first language, sometimes I say something, people might get confused. So when I said oscillating series, that's not what I mean. I mean alternating series, that's the correct name. So yeah, but I will like keep reminding myself not to say it wrong, but sometimes I just forgot. Okay, so what's alternating series? What do you feel about the terminology here? When I first saw it, I feel like, oh, this series must be divergent, but actually it's not. It's actually convergent. So what does it look like? It looks like this, sigma n equals to 1 to the infinity minus 1 to the power of n plus 1 times bn. So when you saw this series, as you can see here, here is minus 1 to the power of n plus 1, right? So when you see it, you kind of feel like, okay, this looks like a series that it will oscillate. So that means it's divergent. Yeah, this feel very straightforward, feel very instinct. But actually, it converges in some case. If your condition under certain condition, it will be converged. And you'll be like, what happened? So let's draw a picture, then you will know why. Okay. So yeah, I still need to draw the first picture, but which is not correct. I mean, like, it's not what I'm going to talk about. So when you see here, you will be feeling like, okay, this series must look like this. Yeah, but actually, that's not what we are talking about today. We want to talk about under certain condition, it will be converged at the end. So let's see. Here, let's say here is your series. We could draw it, so it will be more straightforward. So this one will be looking like these, like S1, S2, S3, S4, so forth and so on, all the way to the S sub n. So what is your S1? S1 just B1. And what is S2? So S2 is B1. Okay, change the color. Minus B2, B sub 2, sorry. Okay, and then here is your S3. So S3 will be, okay, I will use the color. B1 minus B2, and then different color, and then plus B3. I'm a little bit lazy, so let's just take this 3. Okay. So as you can see here, that's the most important thing we haven't assumed. Okay, so we want to assume that B sub n sequence is decreasing. So let's see here, observe, your B1 will be your S1. So let's say your S1 is here, and your B1 will be this distance, B1. Okay, and then you need to minus B2, which you know it is increasing. So B1 bigger than B2. So as you minus B2, it should go down here, but not all the way down because B2 is less than B1, B2 here. So here will be your S2. And then let's do it one more time. So now this one is your S2, right? S2 is your B1 minus B2. And now you want to know the S3. So S3 need to plus B sub 3, which B sub 3 is less than your B2. So it will be going to here. Just don't exceed the point here. Okay, so it will be here, S3. As you can see here, your S2 and then your S4 will be here, and then your S5, so forth and so on. Oh, this is wrong. Okay, this one. Okay, let's draw an imagined line here. I'll move it, don't worry. Okay, change the transparency. Okay, so actually it will converge to this value. So we had a conclusion here. Okay, let's make it smaller. So let's say you see the alternating series sigma n start from 1 to the infinity of minus 1 to the power of n plus 1 times b sub n. If it is, first of all, its limit n approaches to the infinity of bn, it will be equal to 0. Not only for this series, but for the others. Yeah, you can see for the others as well. Some of them, I mean most of them. And also the second, it will be, the bn sequence will be decreasing. And if you have these two conditions, so you will let this alternating series to be convergent. Okay. That's the alternating series.